Hello, mathematicians. Welcome back. Hope you had a good weekend. We are back with a new topic, and this week's topic is all about gaps. And I've got a few things to show you about gaps. Hopefully you can see this. Check out the gap in this GIF. Through the clouds, through a gap in the clouds, vroom. Isn't that cool? It's like Aladdin. I can show you the world. Do, 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 do. Aladdin's a great movie. I used to watch that every day as a child. All right, there you go, your five. That's our first thing about gaps. But also, check out this photo. Do you know what made these little weird circular things? This was during a solar eclipse. So the moon is going in front of the sun, which creates this little halo around the moon. And normally, the sun would go through the gaps in a tree. This is the tree's shadow. And normally you would just see little specks of light where the light was shining through from the sun through the gaps in the tree. But now, because there's an eclipse, it's the eclipse silhouette that is shining through the gaps in the trees to make this cool pattern. So this is the shadow of the tree, and the eclipse light is shining through all of the gaps in the tree. Last one about gaps, year fives. North America has the people that they call Indians, the American Indians, and they don't count with their fingers, I believe. They actually count with the gaps between their fingers. So they go 1, 2, 3, 4, 5, 6, 7, 8, and then they go on to the next set of numbers. Then 11, 12, 13, 14. So their highest that they can get to is 8 because they count the gaps in between, whereas we count up to 10 because we count the fingers themselves. But for this lady, see if you can spot something different. Is it her ring? Is it the desk? Is it her sleeves? No, she has an extra finger on each hand. She has 6 fingers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Very rare, but it does happen. Sometimes people are born with 6 fingers. And so if this person was an American Indian, they would count 1, 2, 3, 4, 5. They have the same number of gaps, 1, 2, 3, 4, 5, as we have fingers, 1, 2, 3, 4, 5. So yeah, there you go, your fives. We are talking all about gaps because sometimes when you are measuring something, you might come across this. This is what's called a graduated scale. It means there are little grades in there, little lines along this whole scale, like a ruler or the speedo on a car or the measuring lines on a measuring jug, maybe if you're doing some baking during isolation, quarantine. But let me show you the strategy for that, and it's all about gaps. So the strategy is count the gaps, not the lines. Count the gaps, not the lines. Make sure you've got that written down in your grid book or on the paper that you're using. Count the gaps, not the lines. Because that means, so you can use what you do know to work out what you don't know. Let me show you what that means. Whoops. Count the gaps, not the lines, so you can use what you do know to work out what you don't know. Let me show you what I mean. We are going to count the gaps between 30 and 40. That's 1, 2, 3, 4, 5. 5 gaps. Okay? But it goes up 10, whatever this scale is. It could be like height scale, so let's call it centimeters. It goes up 10 centimeters, and there are 5 gaps. So 10 centimeters, 5 gaps, and what you do is you divide the length by, by how many gaps there are. And that tells you how much each gap is. So 10 centimeters, 5 gaps, which equals 2 centimeters per gap. Each gap equals 2 centimeters. How many times am I going to say gap? Each gap equals 2 centimeters. So let's count it up. 30, that'll be a gap of 2, 34, 36, 38. For this one, year 5s, we're actually counting the lines. So 32, 34, 36, 38, 40. We use the gaps to label the lines. You can add that to your strategy as well. Count the gaps, not the lines. Then use the gaps to label the lines. Let me put this in bold for you, so you see each part of the strategy. Count the gaps, not the lines. That's what we did, and we got 5 gaps. The overall length was 10 centimeters in this scale. And then we use the gaps to label the lines. Each gap was 2 centimeters, so we can label the line 2 centimeters each time. 30, 32, 34, 36, 38, 40. And if you get to the number on the next part of the scale that it's meant to be, then you know you've worked it out properly. And then you could carry on going 42, 44, 46, 48, 50. Once you've counted the gaps, then you can label the lines. Just like that. So we got it right. Well done. Let's do one more example here. This is like the speedometer. It could even be degree. Oh no, it can't be degrees because this should be 180, not close to 120. So it's a speedo. If you're going at 120, you're probably going too fast and you're probably going to die. So let's look at our strategy again. Count the gaps, not the lines. So let's count the gaps between these two numbers that we have. Only 2 gaps. So let's write that down. 2 gaps, and it is 20 kilometers an hour is the difference between these two lines. That means, so we're going to do 20 kilometers an hour. I'm going to put this on the other side, year 5, so you don't get confused about which way to divide. But we start with the length, and then we divide it by the gaps. And there are 2 gaps. So 20 kilometers an hour divided by 2 gaps. 20 divided by 2 equals 10 kilometers per hour for each gap. So this gap up to here is 10k an hour. This gap up to here is 10k an hour. So 40 plus 10 is 50. So we would go 40, 50, add another 10, 60. We were correct, which means this one is the same distance. So that's going to be 70, 80, 90 over here, 100, 110. Boom, gotcha. So let me just tell you, let me show you. This is the sipping work which you guys are going to start off on. And it gives you a little bit of a head start on here by labeling the individual lines already. But we can use what we know. This is the last part of the strategy. Use what you do know to work out what you don't know. So each line is worth 1. That's what we do know. These ones we don't know. They're not labeled. But we can see that it's plus 1 every time. So we go 11 mil, 12 mil, 13 mil, 14 mil, 15 mil. There we go. And we will be able to use what we do know to work out what we don't know. And just like we did, they showed the amount that the scale is measuring, 5 mil between here and here, same over here. Divided that by 5 gaps, because there's 1, 2, 3, 4, 5 gaps. So each gap, each graduation is 1 mil. Each gap is 1 mil. And then we write that on the lines. an extra mil there, 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 and there gives us 11, 12, 13, 14. So there you go, year fives. This is the most important step. See what the difference is. 20 and 10, the difference is 10 mil. Divide that by the number of gaps, and then you can label the lines. That's what this strategy is all about. Count the gaps, not the lines, and then use the gaps to label the lines after you've divided. I might even just put that in there quickly, year 5, so you don't skip that step. Divide the difference in scale by the gaps. So the difference in scale for the one we did here, difference in scale was 20. And then we divided it by the number of gaps. We're finding out how much each gap is worth. So there you go, your fives. I know that's going to be a little bit tricky maybe, but you guys can do it. Jump on the Zoom call if you have any questions. I'll be there the whole time. And just work through this slowly. That's why we're all starting on sipping this week, because it's a bit of a weird concept that you probably haven't started before. So we're all going to start on sipping. Make sure you correct your work. Answers are down the bottom. Make sure you correct your work before you upload it, and then I can give you proper feedback. All right, thanks, mathematicians. See you later. Bye.